So welcome. We're going to talk about full stack cloud native packaging, an intro to CNAB. So my name is Ben Griffin. I am an Azure technical specialist focusing on open source and cloud native technologies. I work as Microsoft in part of the Global Black Belt team.
Hi everyone, I'm Clarence Bakotidis. So similar to Ben, I also work in the Global Black Belt team across Asia, focusing on cloud native solutions.
So cloud native applications are generally made up of many different parts. So who in the room here, for example, is using tools that we display here? Put your hand up. Yep. And that's congruent with what we heard this morning through Cheryl at the CNCF with her poll, also with Andrew from IBM. You know, we have our cloud native applications that are complex, they're hard to deploy, there's lots of moving parts. So what we need to do is we need to look at how do we manage the middleware, the infrastructure tooling, how do we manage it moving to multiple clouds? How do we ensure that when we're deploying our cloud native app that the admin knows how to do this work for us? There's a lot of domain knowledge kept up in how do you deploy these quite complex distributed applications. So Docker has helped by simplifying some of this process by allowing us to package up our deployments for our real-world apps, but there's still a lot of many moving parts that we need to still configure and manage. So how do we simplify the delivery of these applications? So who's been in the situation where you're deploying your cloud native app and you've got to go to GitHub and you've got to follow a big laundry list of items, right? We've all been there, right? GitHub, or we go to an internal wiki or something like that, and we've got to follow this whole big list. Now, when we're doing that, you know, we've got to follow setting up our infrastructure, setting up our DNS, setting up, SSL keys and things like that. Not to mention our application in question as well. So we uncover these type of problems where we've got lots of steps we need to follow, and because we've got lots of steps and we're human, we're prone to make mistakes, of course. The other thing we need to consider is when we're following these steps, the person who's written them, a lot of their domain knowledge or, brain is not like leaped onto the page properly and might miss certain things. They might say, configure DNS, and you just go, how do I do that? Or create a SSL key or SSH key. How do I do that? I don't know. So, there is a certain amount of domain knowledge as well required with setting up these domain apps as well. So what we want is a repeatable way of having an end-to-end process that will just work for us every time the same way. Now, containers solve part of this problem, of course, but you've still got other moving parts that we need to worry about. Again, we still have the infrastructure component that we need to set up. We've still got to, like in this instance, we've still got to think about how do we install Helm? How do we install like Kubernetes, for example? These are quite complex things. How do we set up TLS? So what if there was a way that we could package all of this all our application logic into a single bundle that we could then verify and know exactly what it's going to be doing and have this repeatable every single time? So imagine if we can install this artifact into a single tool. So, introducing the Clippy tool, but no, not quite. But what we're trying to say here is that you can just have your application, it's tagged, it's got a version, and here's my application, go and run it for me. So wouldn't it be nice if we had something that could do that for us? So this is where we're going to introduce you the Cloud Native Application Bundle, so CNAB. So CNAB is a packaging and installation specification that aims to safely distribute our application repeatable way over and over again. It's an agnostic specification that has been created jointly with Microsoft, HashiCorp, Pivotal, Red Hat, and Bitnami, and Docker, of course. So the idea is it facilitates bundling up and installing of our application, including the infrastructure, so such as cloud storage, such as DNS or load balancer. It also can be cryptographically signed as well, so it can be verified, which is important. So let's talk a little bit about what a CNAB bundle is. So we have our application image or app image. Now, essentially, this is just really a Docker image, no different to what you do today when you're creating a Docker file and creating a Docker image. We have something called an invocation image. Now this is a Docker image, but this contains all of the tool chains needed to install your application, such as Terraform, or your shell scripts, or stuff to do with Helm, whatever it could be that your application needs, we can install into this invocation image. If you had like a Postgres database, all the schemas and things like that we could run to set up as well. So it also contains all the configuration data and metadata and templates and things. So think of this a bit like an MSI package from the Windows world, or think of this like a bit like apt-get type of thing for Linux. We also have something called a bundle descriptor. So it's a lot like a Docker image again, like a Docker specification image. It's a JSON file, but what this bundle descriptor does is it basically lists out in this JSON format what the invocation image needs to run. It lists all the application dependency it needs to run from the app images. The definitions and inputs and outputs as well that you can specify. And finally, it can be signed. Now, all this goes into this CNAB bundle, and this can be bundled up, essentially, and then shared with an OCI compatible registry, such as Docker Hub or in Azure, Azure Container Registry, etc. So let's talk a bit about what the invocation image is. So as I mentioned, it's essentially a Docker file, or a Docker image, but it has a very specific structure, as you can see on the right-hand side. So in this case, we're saying we're using like Azure CLI, or we're using ARM templates, or if you're from AWS, CloudFormation, Helm templates. All these things can be actually dumped into this file structure for our application to run. Finally, what you can do is you set like an entry point into this invocation image. And so therefore, what is it going to run? Is it going to install, update, and these things? And this is something we'll explain in a moment. Finally, we want to talk about how do we implement a CNAB, or a Cloud Native Application Bundle. So we've got Porter, which is an open source project created by Microsoft. Porter is part of a joint development foundation, which is part of the Linux Foundation. And essentially, it packages up all your artifact and tool chains, so we've talked about Terraform, Helm, scripts, etc., into a format, and then it uses something called mixins that we'll talk a bit about later, how they work. Finally, what you can do is you can use Porter to just deploy our application, a bit like what we saw before with Clippy. We also have Docker App, and this is Docker's implementation of the CNAB specification. It works along the same type of Docker app workflow, so quite similar to how you do your Docker image workflow at the moment. So you create an app definition, you build the image, and then you share that into, like, say, Docker Hub or something to that effect. Now, today, as I mentioned, we're going to focus on Porter and what we've done here at Microsoft. And on that note, I'll hand it over to Clarence.
Thanks, Ben. You can just leave it for now. Cool. So, Porter. So as Ben mentioned, there's a few different implementations of a CNAB specification, or at least tooling to support working with CNAB bundles. So Porter is the one that we're going to focus on. So what is Porter? So Porter helps you, it's tooling to help you create this CNAB bundle. CNAB is a specification. If you look at what's contained in there, it's designed to be machine readable, it's designed for machines. Porter kind of simplifies the process of building these CNAB bundles, and it's designed for developers and humans to read. The great thing about Porter is it's not only about packaging up just your application, but also the tool chain to deploy your application and configure any supporting infrastructure needed. Once you have these bundles, you can actually then share them, so you can push them, pull them from a Docker registry like Docker Hub, for example. And quite an interesting thing is a use case where you might want to have a self-contained bundle that actually contains all the connected pieces. Think of like a big tarball that you might want to share into an air-gapped environment. So there's a use case for that where you can actually support a self-contained installer. And lastly, second last I should say, Porter can be used from the command line, but there's also scope for building graphical user interfaces and self-contained installer, self-runnable installers as well. And you can extend Porter, so as you'll see later, that we have a lot of existing modules called mixins that kind of help you to install your applications and deploy them. but you can also add your own extensions to Porter. So how do you work with Porter? There's two main personas that we'll look at. So as a developer, you're going to create a new directory and then run porter create, which is going to scaffold you a number of initial files that you'll edit. And once you add the steps that you need to deploy your application, then you'll run porter build. Now you'll notice with these commands, there's no additional arguments because we're running them within the scope of a directory where we're developing on the source code. Now, typically when you deploy applications, they're going to use some resources that need credentials. So think of, for cloud, you might have some access keys. For databases, you might have some passwords, etc. They're not going to be stored in the bundle for obvious reasons. So there's a step to essentially generate a credential file that's stored on your machine. Then you can install the application once you've built the bundle. And if it doesn't meet your expectations, then you can iterate on that. So then you can make some changes to the code, build again, and then install as necessary. And once you've got something you're happy with, you can tag that and have it pushed up into, say, something like Docker Hub. Now, as a consumer, you're not going to necessarily have the source code that was used to build the bundle. So let's say Ben over here has built this application, and Ben says, hey, Clarence, try out my app. So he gives me a name and a version number. Now, I want to know what this app is and what the requirements are in terms of credentials and parameters. So I can actually run a command called porter explain. And porter explain will show me some information. And we'll see this shortly in a demo to make it more concrete. I'm going to generate the credentials necessary and install the app using that specific version and tag. Now, there's also scope for upgrading applications. So when updates come, I can then update my application. And finally, if I'm done with the application, I can have it uninstalled. And the great thing here is, as a consumer, I don't care about the tooling. So whether it was using Terraform, Ansible, Helm, whatever you want to use internally, I just know how to use Porter. And this can actually be used with other tools. So if I use Porter to build the CNAB bundle, I could actually use like Docker app or another tool to install the bundle. Now, when you create the initial Porter project, you get 3 files, as you can see here. The main one and the one that's sort of mandatory is porter.yaml, and that's sort of where the magic happens in terms of the steps you want to perform. Now, if one of the mix-ins doesn't do what you need, and you don't want to create a mix-in, you potentially can add additional binaries or other files needed during your deployment process into the Docker file. So you have the opportunity to customize the Docker file that's generated. But if you don't need to do that, you don't have to touch a Docker file, and one's generated for you on the fly when you build the bundle. So if you look up here, this is a sample of a Porter YAML file. And I'm not expecting you to read every line of it, but I'm highlighting some of the important bits. So declaring what mix-ins we want to use. So here we're using an exec mix-in, which is kind of the easiest one to use when you can't, or not the easiest one, but let's say you can't find a mix-in that does a higher level abstraction, then you can fall back to exec and execute any task you need. Kubernetes mix-in knows how to apply manifest to a Kubernetes cluster. And here we can declare what credentials we need. So for Kubernetes, you typically need a kubeconfig file. So we're not going to package that up. We're expecting someone to supply a path to where we can find that. Here we have some metadata that explains what our bundle does, and its name and version, and also what the invocation image is, and the tag is the bundle itself. And you'll see there's actually 2 parts once we publish this image or this bundle. Here's the installation process, the uninstall, and there could also be an upgrade path in here, which we don't have on this slide. And lastly, we've got outputs. So for example, if we're provisioning a web service and we want to know what the IP or FQDN or the domain name, we can output that for the user to then try the app out. Now with mix-ins, these are the ones that are currently available, but you can create your own and contribute those back. So for example, Helm lets you apply Helm charts. Kubernetes lets you apply Kubernetes manifests, and as you can see, we have other ones for different cloud providers and Terraform. And the beauty here is these encapsulate the knowledge of what tools do I need to install, Are there any additional steps that are needed? For example, if you're using Helm 2, you need Tiller in your cluster. Well, the Helm mixin would actually go and install and configure Tiller for you, so you wouldn't need to know how to do that as a consumer. So with the mixins, you can also get hold of outputs, and you can use those outputs in subsequent steps. So for example, if I provisioned a service and I have an IP address, I might want to add that into a load balancer in a subsequent step, so I can actually reference that output. And likewise with Helm, for example, we might have produced, say, a database, in this case MySQL, and I want to get hold of the password from the secret that was generated. Okay, now let's look at a demo app. So this is called Spring Music. It's a Spring Boot application that is containerized and deployed on Kubernetes. Now the interesting thing here is, which I'll get to in a second, is that it uses Kubernetes. So it could be any Kubernetes cluster, and it also deploys a database out into DigitalOcean, so a Postgres database. And I've already packaged this up, so that's the CNAB reference to pull that down. So what I'm going to do, I'm just going to switch out to mirroring mode, because I think this is going to be a bit easier for me. So, okay. Right, so what we'll do is we'll kick off the installation. Now, you know how live demos are. I do have a backup recording, so let's kick off the installation and we'll come back to the slides and look at what the architecture for this bundle looks like. So here you can see I've published my bundle, and you notice there's two parts. There's the invocation image, which is the second entry, and then the bundle itself. So the bundle is actually a JSON file, but because registries, if they're OCI compliant, so Open Container Initiative compliant, you can actually push other files or layers up to those registries. So in this case, we can push the JSON file, which references additional images. So the first thing I want to do is I want to understand what's in this package. So I'm running the explain command. So the explain command is telling me Spring Music, it runs on Kubernetes and it uses DigitalOcean Postgres. And here I can see some credentials that I'm going to need, as well as parameters. Now, the parameters have some defaults that I can override, and at the end I can see output is going to be a service IP address. The next step is to create some credentials. Now, the bundle itself specifies the credentials it needs, and you can supply these in different ways. So for DigitalOcean, I'm going to supply these via environment variables. I'll explain these a bit further shortly. Live demos, secret. So these are the three pieces I need for DigitalOcean, and for Kubernetes, I'm just going to use a kubeconfig file from a file path. So just paste that in, kubeconfig. So now we're almost done. We have a credential file created, but I need to actually have those credentials available, because a credential file is essentially a pointer to those. So the first thing I need to do is I need to source those credentials from an environment file. All right, so I'm not going to show the credentials, but I'll show you what essentially is in there. So you can see here I've got the three credentials I'm sourcing into my environment. And lastly, I need a Kubernetes config file. Now, because I'm using AKS in Azure, I'm just going to tell it, please give me the kubeconfig file for that cluster I already have running. Cool, so now we can actually run the installation. So the installation, you need a name, the bundle you want to install. Then you can see the -c is the credential file reference that we configured. And then I'm overriding some parameters because I want my database called, for example, a certain thing in DigitalOcean. Right, so that's going to run through a few steps. Now, in the interest of time, let's switch over to the video. And it's always good to have one of these, but we can see now it's running Terraform. Terraform's doing its thing. All right, what's going to happen after Terraform is we're going to provision a database, and then eventually, after the database has been provisioned, as you can see here, we ran Helm. So Helm has created a deployment, a pod, and a service in Kubernetes, and now there's a script waiting, polling for the IP address, the public IP address to be available. So if you fast forward ahead, we've got the IP address, and you can actually ask Porter, like, show me some of the outputs. So here we're saying, show me what Spring Music's outputs. We've got an IP address, and then we can paste that into the browser, and in a moment, as you'll see, we'll have the Spring Music app up and running. So that didn't really require any knowledge on my part. I just had to provide the credentials. Now, as you see, it's still running in the background, but we'll leave that. Just want to show you one more thing before we cut back to the slides. So, because I'm using DigitalOcean, I've got a command line tool, so I'm querying for the database. It's showing me, yep, there's a Postgres database, and I'm also querying for some blob storage that was created. So let's have a look at that now in a diagram in case there was some confusion as to what was happening. So I, as a user, ran Porter, and I said, hey Porter, I want to install this bundle. This bundle comes packaged with a few mix-ins, as well as instructions on how to install the application. Over on the right, we've got DigitalOcean. So the first thing we want to do is create essentially like a blob storage account. Because if you're familiar with Terraform, it creates a state file that represents the state of the infrastructure it's provisioning. You need to store that somewhere safe, so we store it in blob storage. Then we run Terraform. It stores its remote state, and then Terraform creates the Postgres database in DigitalOcean. Next, we're using an existing Kubernetes cluster. Now, we could have created the bundle. We could have told the bundle when we designed it to create a cluster for us, so that's a design decision. Or you might have an option that says skip creating cluster. In this case, it assumes there's an existing cluster. So it runs Helm install, we get a pod service, the pod pulls down an image from Docker Hub that's already been previously published. And that's basically an example of a bundle. Now, a bundle could be more complex than this. It could be simpler. It's really up to you and your imagination what you can produce. So here I'll pass over back to Ben.
Thanks, Clarence. So what we've seen here is that deploying our cloud-native application is going to be a complex task generally because it's involving many, many moving parts. So we want to look at reducing that complexity and make it easier. So CNAB allows us, or is a specification that specializes in how do we actually reduce that complexity. And then we're using a tool such as Porter or Docker App to be able to implement a simple way of you being able to deploy a cloud-native application that is quite complex to deploy. And as we saw with Clarence, we had something that had Helm in there, it had Terraform in there, it had a Postgres database, it was configuring something in DigitalOcean. Now me as a user, I just have to log in, create my Porter, new install, and away I go. So I don't have to know anything about how Helm works. I don't know how to provision a Postgres database in DigitalOcean. So as you can see, it simplifies our deployment process quite significantly. In terms of resources that you guys can have a look at, or people you can look at, I should say. So you've got the CNAB specification. As I said, this is open source, and so if you look at cnab.io, we've got Porter, so porter.sh, and we also have some working examples on Azure as well that you can have a look at, as well as Pack Your Bags application, which is just a simple thing, tutorial run through from zero to hero. And finally, in Azure, we have some quick start examples that you can use as well, which link into our tooling. Let's check if it's installed.
The slowest part is actually the DigitalOcean Postgres database. It varies. Sometimes it can be 3 minutes, sometimes it can be 10 minutes. Let's have a look. 450, so it's still going. But are there any questions before we conclude?
For an app that's more complicated and wants to have internal TLS certificates generated and that sort of thing, is
Yeah, so for example, if the mixin does what you need, for example, if you're using, say, Cert Manager in Kubernetes to generate certificates with Let's Encrypt, or, for example, then certainly you could provision that step. If it was in a cloud, let's say it's in Azure, you could use an ARM template. If it's AWS, you could use CloudFormation. It's really up to you. You can put whatever you like in there, and there are pre-existing mixins. So it's really, is there a mixin that supports what you need? And if not, you can always fall back to an exec command, or you could create a mixin yourself.
Sorry, I'm going to keep asking questions.
No problem.
Front, I have no idea how many hands behind. So, how many, so, say, with my bundle, therefore, assume that Cert Manager is installed, and therefore it's less portable because you start to make assumptions about what's on that target Kubernetes.
No, so you would actually install all the things you need in the cluster as part of the bundle. So the consumer shouldn't need to have those things pre-installed. The description can say, for example, you need to have a Kubernetes cluster, but that's it. So for example, the demo we use, it doesn't assume there's even Helm installed. It will install Tiller for you, set up the RBAC roles necessary for Helm to work. So it should be self-contained. And if necessary, we could have it generate the whole cluster from scratch. All you would need to do is provide your access keys to your cloud provider of choice. Yeah.
And then if you're thinking from an air-gapped environment,
Go on.
Yeah. If you were thinking about from an air-gapped environment, what you could do then is you could basically export all that detail out into like a tar-z file and then basically push that into an air-gapped environment that have everything self-contained. So you think of that as being a thick bundle versus something being a thin bundle. It's going to access the internet and pull everything down for you. So it's up to, as Kaz was saying, the application designer who creates all the bundle to have all that in for you, and you as the consumer, you don't need to know that type of information.
So it worked. Yay.